Hi, welcome to Mathematics with Tom. I'm Tom, and today we are going to look at finding the standard deviation and the variance from a frequency distribution. So let's come to the chalkboard and we'll get started. So we're going to find standard deviation from a frequency distribution. Okay. So let's do a quick review. So remember this. The population, let's look at this. The population variance, this is a bit of a reminder, but I think it's always in good order. The population variance is sigma squared, and I'm going to abbreviate population like this, and the population standard deviation, we're going to just use that like we did in our last class. And the population standard deviation is the square root of the variance. It's the square root of the variance. And we simply write sigma. Remember this is the lowercase Greek letter sigma. The capital one is the big E that means the sum. Now, what we find is these, before we go on, there's something important to remember. These are parameters. These are parameters, i.e. the population. And not only that, and usually we don't calculate these. We do not calculate these. Okay? Now, what we do calculate is the statistics, and the statistic is calculated from the sample. So we call them sample statistics. We calculate sample variance and that's represented by the lowercase s squared and the square root of s squared gives me s, which is sample standard deviation. Now remember, the subtlety here, and we're going to write that here in a moment, is that the formula for calculating the variance or the standard deviation for a sample is actually different than the formula for calculating the variance or the standard deviation of a population. So because of that, you need to be careful. And let's write that down. We said that the variance is equal to the sum, we add all these up, the data values minus the mean. You square all those, and then we're going to divide that by, it's not just n anymore, there's a correction. We divide this instead by n minus 1. And we called n minus 1, it's a result of what's called Bessel's correction, but we call it degrees of freedom. Degrees of freedom. Okay. Now, let's see. I think we're ready. Let's find a standard deviation from a frequency distribution. So, here we go. I'm going to write this. I think we have just enough space, probably right here. So I'm going to put class and frequency. I'm going to write it a little small here so I can just fit it in. Now, when you're making this line, I'm going to carry my line out to the right a little bit, and you'll see why. So give yourself some extra space off to the right. And then I'm going to write this, let's see. So my class is going to be from 1 to 2. Oh, no, sorry. Don't use that. How about this? How about 0 to 1, 2 to 3, 4 to 5, 6 to 7, and finally my last class will be 8 to 9. Okay. And the frequency, let's give these a frequency. How about the first one, let's make this class a frequency of 5. The second class, 12. How about the next class? Let's give it an 8. It's an 8, and maybe we'll do a 6 here and a 9 here. Okay, and I don't really have space here, but if we add these up, our total there is 40. Let's just double check. There's a 10 right there. Oh no, I'm sorry, not a 10. There's a 20, and then there's a 15 and 5 more for another 20. So we have I'll write this here, our n, our total number of data is 40. And normally, hopefully you have space, you would have written yours right there. Okay? So that's our sum. Now I left another column, and here's why. Notice, we've actually seen this data set before, but what's interesting here is a couple of things. One is, when we talk about the data values in the class from 0 to 1, there's 5. There's 5 data values. They could all be zeros, they could all be 1s, or they could be a mix of zeros and 1s. And we don't know. So what we have to do is we have to use our best guess. And what we do is we represent each class with the midpoint. We represent each class with the midpoint. So we're going to use x for the data values, m, the midpoint. And remember, a midpoint is very simply the average of two numbers. So we're going to calculate that in a moment. This is as a quick review, we've talked about class limits and class boundaries. And in this case, this frequency was given to you in class limits. So it's always just a good review to make sure, or just to be comfortable, am I looking at limits or boundaries? These are limits. Remember, boundaries would be minus 0.5, 1.5, 1.5, 3.5. 3.5, they would share that boundary. Okay, let's come over here. Our midpoint, a midpoint means you take the first value, you add it to the second value, you divide it by 2, well that's just a half. I'm going to write that as 0.5. And then we the same. So our next midpoint is going to be a 2 plus a 3. We're going to divide that by 2, and that's going to be a 2.5. And notice that our class width is 2, so it looks like each of these will go up by 2. So I bet you this next one will be 4.5, 6.5. Let's see, but let's just see if we're on to that. 4 plus 5, so our next one is going to be, take a 4 and a 5, that's a 9, but we divide 9 by 2, there it is, there's 4.5. And so we can see that each one is increasing by 2. Our next midpoint will be 6.5. Our next one will be 9.5. Okay, now, my line was really going downhill there. There. So, here we go. We're ready to calculate this. So now for our x's, we're going to represent them with midpoints. And, we don't have the mean. So this is a good review. Let's do that. Let's just calculate the mean of our data set as well. So how do we do that? Well, it's it'll get us warmed up with our standard deviation. Here we go. So the mean of our data set, it says you take your first bit of data, they're 0.5s. 0.5. Now, wait a minute. Do you then just add 2.5 and then 4.5? The answer is no, because remember, this first class has 5 data values. We're representing all of those with a 0.5. So we could write plus 0.5, plus 0.5, plus 0.5, plus 0.5. Or all that repeated addition can just be written as multiplication. Okay? So then, our next class, the data values are 2.5s, and we have 12 of them. Plus. My next data set is the 4.5s. Let's look at this. The 4.5s, and we have 8 of them. So 4.5 times 8. Plus 6.5, of which we have 6. 6.5. 6.5, we have 8. 6. I'm sorry, we have 6. Plus our final one, these are, I made a mistake. That's a 9.5. That's an 8.5. You shouldn't let me do that. You should have said something. We got it fixed just in the nick of time. So our 8.5s, of which there are 9, 8.5s plus 8.5, of which there are 9. Okay, I'm going to take, and now we're going to add all of those and divide by our number of data. That's 40. Now at this point, you may just zip through this quickly with a calculator. I don't blame you. I'm going to just do this. I think the arithmetic is a good practice. So 5 times a half times 5 is 2.5. That's going to be 30. Plus, we have 4.5 times 8. That's 32 plus 4 more. That's 36. Plus, then I take 6 times 6, that's 36, plus another half of 6, that's another 39. Plus, then we take 9 times 8, that's 72, plus 9, half of 9 is 4.5, so that's 76.5. That's what I'm coming up with. You should check. Divide that by 40. This is a lot to do in my head for me, so I'm going to simplify. 2.5 and 76 is 79. Plus, that's a 66. 66 plus, well, if that was a 40, it'd be 106 but let's subtract 1, so that would be 105. Divide that by 40. So what do we have? This is 184. 184. Divide that by a 40. Now, I'm going to think of this 40 as a 2 times a 2 times a 10. So if I take half of 184, that's 92 over 20. Half of 92 is 46. 46 over 10, and there's my answer. So, the mean of my data from using the frequency distribution is 4.6. Now, let's calculate the standard deviation. I think we're ready. So let's do this. I'm going to adjust the camera, so stay right there. Okay. I think we're ready. Let's find our standard deviation. So we're going to first find the variance. And why? Well, because the variance is actually the easier number to get first, because you don't have to deal with that big square root. So let's try this. So remember our variance, if we use our variance formula here, says we take the data minus the average of the data. We're going to square that, but we need to remember that we had to do that 5 times, so we'll just multiply each group by 5. So we have our first data is 0.5 minus the mean 4.6 squared times the number of data, 5, plus, remember the number of data, so that's the data. That's the number of data values in that class. So our next one is 2.5. Our mean is still 4.6. Our frequency this time is 12. 12. So what do we do here? This is going to be a 2.5 minus 4.6 squared times 12 plus. This is going to be, parenthesis, 4.5 minus the mean of 4.6, square it, and then we had 8 of those, plus 6.5 minus 4.6 squared times 6 plus, so I might be going a little fast, so the last one, here was the data, 6.5s, there were 6 of them, and our last ones are 8.5s, there's 9, and again the mean is still 4.6. So, coming all the way over, we have our 8.5s minus the 4.6s squared times what? Times 9. Now, we're going to take and add all of that, and we're going to divide it by, and this time, remember, it's not just the number of data, it's the number of data minus 1. So that's really going to be a 39. Now, at this point, that's really difficult for me to do for you. So I would take a moment, put the numerator, the numerator, put this into your calculator. If you do, I've already done that, let me check. Your result should be 295.6 and the denominator becomes 39. Now, you could hit divide and you'll get some decimal, but I would encourage you not to, and here's why. Because as soon as you get a decimal, at some point you're going to stop it. And you create rounding, and then you're going to round the next answer. And you might get so much rounding that your answer differs. So make rounding the very last thing that you do. So this, when you leave the fraction like this, not as a decimal that gets rounded, this is called an exact answer. So let's use our exact answer when we calculate the standard deviation, then we'll make our rounding. So remember this. Remember that the standard deviation S is found by taking the square root of the variance. Well, the variance is 295.6 divided by 39. Take the square root of that number, and I believe you're going to get 2 point, and it goes out. It goes like 7, 5. Goes out a long way. 30803, and it just keeps going on and on and on. Make sure I wrote that correctly. 75308684. Okay, 86 goes on. Now, but remember our rounding rule. Our rounding rule says this. Since our data is in whole numbers, we're going to match our data. So our data is in whole numbers, then we're going to round, or we're not going to match data. We're going to go to one decimal more than our data. So what we would do is round, and we would say that the standard deviation is 2 point. And that is how you calculate the standard deviation from a frequency distribution. Thank you.